And we're going to work on example 1. Okay, example 1. Okay. So I want you guys to go over this, just read the word part, the word problem part first, and then tell me, is this a numerical variable or is this a categorical variable, right? I want you guys to work on that, okay? So go over this and tell me, maybe you're able to fill in some of the quantities as well. What is the population proportion? What is the sample proportion? And what is the sample size, right? I want you guys to work on that. Okay, so think about it.
So then would the n be the 500?
Okay, so Amy, right? Is that Amy?
Yes.
Okay, so Amy said n is 500. Okay, so let's take a look. So it says assume sample size associated with both findings is 500, right? Okay, so n is 500. Do you all agree? This part should be easy, 500. Okay, but you haven't answered my question regarding the data, the property of the data yet. So is this a numerical data or is this a categorical data?
Oh yeah, I think it's categorical.
Why do you think it's categorical?
Because it's just like they use the internet or not, like yes or no, or like they're married or not.
Yes. Okay, very good, very good. Thank you. Thank you. I'm really glad that you are using that. So remember, for categorical data, we are talking about yes or no, right? Yes or no. Okay, so over here, it could be married versus not married. Do you use the internet or do you not? Right, okay, so it's a categorical variable. If it's a categorical variable, this should give you a hint that we are dealing with proportion problems, right? Proportion problems. Great. And how about the p-bar? Do we know the sample proportion for the first problem we have? We're talking about use internet. So what is the p-bar? So p-bar, sample proportion. Sample is 500. So out of 500, I think we are talking about using internet. How many of them out of those 500 actually use internet?
So I think it says it would be 93% of them. So
Very
that's
good.
465 people.
Yes, yes. So how did you get that number? You just use 500.
I did 500 times 0.93.
Okay, and what number do you have?
465.
Okay, so do you think p-bar is 465 then?
Maybe.
So what is a p-bar? P-bar is sample proportion. So p-bar represents the proportion of your sample who says yes. So typically p-bar is between 0 and 1. This part is super important. P-bar is between 0 and 1. So if you can't possibly have a p-bar that's 465. So what is the p-bar then?
0.93.
0.93. Is this part clear how I got it? P-bar represents the proportion of your sample who says yes. Good, good. Okay, great. Okay, so so there are several other things I want you guys to focus on here. So from the wording of the question, it says develop a 95% confidence interval. So this is a confidence interval problem, and we should use the right formula for confidence interval. Okay, if you go back to what we had before, we are dealing with a proportion problem, and the formula we have, confidence interval for P, population proportion, is given right here, right? Okay, so that's the formula we want to use. And once you figure out the P and also P-bar, we should be able to solve this problem quite easily. Okay, so let's see how we can do that. Okay, so what I like to write down is, okay, so a 95%, okay, 95% confidence interval. I like to use a CI, just short form for that, for population proportion. Again, it is very, very important you see this part. Oh, sorry, used the wrong one. Okay, so this is a P, not a P-bar. Okay, you should never have a 95% confidence interval for P-bar at all. Why is that? Why can't you estimate a P-bar? Why can't you estimate P-bar? Can you estimate P-bar? You cannot. The reason is because we know P-bar is 0.93. We know it is 0.93, right? If you know it for absolute sense, you know exactly it is 93%, why do you want to estimate? You know this is 600, you don't want to estimate, right? You only estimate a quantity with a confidence interval or maybe point estimate if you don't know that quantity. And the quantity we don't know is a P, population proportion. The proportion of the entire young adults population who maybe get married or maybe who use internet. That's a much larger size, population size, and we cannot possibly estimate it. We cannot possibly have the actual quantity, so we're going to estimate. Okay, so let's see, 95%. I'm going to just plug in the formula. Hopefully, you guys, have already copied it somewhere. So it's going to be it's going to be it's going to be P bar plus, that's going to be the point estimate plus minus MOE, right? That stands for the interval, okay? Because whenever we talk about interval is going to be something like that. And the center of this interval for this particular example is going to be P bar, and MOE refers to the width of it, right? Okay, that's why you have the P bar plus the MOE part, and the lower bound, that's going to be the P bar minus MOE, right? Okay, so this is the interval. Okay, let's take a look. So it's going to be P bar plus minus a Z multiplier, multiply, okay, P bar 1 minus P bar. This is great. This is much better than me writing using the mouse. I like it. Okay, great. Right, so this is the formula. Okay, are we able to plug in all the numbers we have? Do we have all the numbers we need here? Do we have P bar? Do we know it? We know P bar, right? Okay, we also know N. How about a Z here? Do we know the multiplier?
Yes, don't we know it from one of your presentations, like for a 95% confidence, it's like 1.96?
Okay, this is very, very important. Okay, I'm glad that he mentioned it. So for 90%, 95%, and also 99%, there are three magical numbers. Typically, I would ask my students to memorize them. It's just three numbers. It should be straightforward. Okay, and 90%, that's going to be 1.645, and this is 1.96. I think this is a 2.575. Okay, so these three numbers were obtained using the Z table. Okay, so you can look them up using a Z table. Alternatively, you can write it down on a note card, and so every time you see 95% for Z multiplier, okay, you can use 1.96, right? Okay, I think it is 1.9. Okay, so you can come. Okay, so let's see. So you guys see there's a Z multiplier we need here, and because we know it is 1.96, you can fill in here, right? Okay, that's going to be 0.93 multiply 1 minus 0.93 over 500, right? Any questions on this part? Okay, well, so we can continue this 0.93. Make sure you guys have a calculator so you know how to calculate. So the first thing is you want to multiply the second part together. Okay, you multiply them together, and I've already done the math. So that's going to give you 0.02236, right? Okay, and so this is a margin of error, this part 0.2336. And if you add them up, or if you subtract them from each other, you will be able to get a lower and upper bound. Okay, and that's going to be 0.9076. So this is called a lower bound. This part is called a lower bound. And upper bound is the bigger one. Okay, 0.9524. If you already watched my video, you know that in my slides, in my videos, I like to put the smaller number first. This represents the lower number, the lower bound. I like to put the bigger number next because this represents the upper bound. And the reason is because it makes sense intuitively. We are talking about a real line, a real number line. So you're going to see 0 here, 1 here, 2 here, and so on and so forth. So certainly a smaller number, a lower bound would be on the left side, and the upper bound would be on the right side, right? Okay, and you can go in to fill in the numbers. And so what does the confidence interval mean? So that's why we have to talk about the interpretation of the confidence interval. Okay, so this means, At a 95% confidence level, proportion of adults of the entire population here between 18 and 29 use internet is going to be between about 91% to 95%. So on average, it's going to be between 91% to 95%. So P bar, this time we're going to talk about the proportion of adults who are married here. Okay. So married, let's go back to what we have here. I think we're talking about, let's see. So another finding says 21% of those are married. So 21%. What is the 21%? That's going to be the sample proportion, right? The sample proportion. Okay, so everything will be fairly similar. So this is going to be 21. And again, the sample size is 500. Okay, so every single thing is the same. Okay, I'm just going to write down here. It's going to be 0.21 plus minus 0.21 times 0.79. Okay, make sure my calculation is right. No. Okay, over 500. Okay, the only exception is the multiplier part. What is the multiplier? The reason I say this is different because, because we are talking about 99% confidence interval this time, right? We're talking about 99%. Okay, and so what is a 99% confidence interval? The multiplier, what is it? Okay, it is a 2.575, right? This part. Okay, so you can 2.575. Okay, so this is going to give you 0.1631, that's going to be the lower bound, and 2569, right? So you can convert those two. You can convert those two in terms of the proportions, right? Okay. So I'm just going to round it to, 0 decimal. That's going to be 26%. So for part B, we were talking about 99%. And this is the interval we get, 17% to 26%, right? Okay, so this is the interval we got. Awesome. Okay, so if this is a real line, okay, I think it's going to be centered at a 21%. And so this is the interval we have, 17% and 26%. And this is for 99% confidence interval. I want to ask you a question. What if I'm going to change this to 90% confidence interval? What do you think? Okay, so where do you think is the center of this interval? Without doing any calculation, I want to ask yourself, your intuition, use your intuition. Where do you think, if I change the confidence level from 99% to 90%, what do you think is the center of this interval?
Is it still at 21?
It's still 21%, right? This part doesn't change. Okay, how about the wave of the interval? The wave. Previously, this part is the wave. From 17 to 21, that's a 4% difference. So it's going to be this part. Wait a second. You guys didn't even correct me. When I round this one, it should be 16, right? Right? If you round it, it should be 16%, right? So when I change from 99% to 90%, do you think it's going to become wider or is it going to become narrower? So narrower means the interval is going to be from here to here. Wider means it's going to be from here all the way to here, right? What do you think? If your confidence level drops, that means it moves from 99% to 90%. It drops. What's going to happen to your confidence interval? Is it going to become narrower or is it going to become wider? So your confidence level actually dropped. So your confidence means, how confident you are with this interval estimate. I think it's going to be anywhere between 16 to 20%. I am 99% confident. Okay, 99% confident means on average, 99% of the intervals I developed use any sample of size 500. 500 students, anywhere between 18 to 29 years old. Okay, I can develop a new interval, and this interval is going to contain the true population proportion, which is P. Okay, I'm going to be 99% confident. That means 99% of the intervals I developed will indeed contain the true population proportion. Okay, now I'm going to relax my interval confidence level a little bit. Instead of to be 99% confident, I was like, okay, 90% is good enough. I just need 90% of my intervals contain the true population proportion. I don't need it to be as high as almost 100%, 99%. It doesn't have to be that way. 90% is good enough. So do you think my interval is going to become wider or narrower? Okay, so do you think it's more likely for a wider interval to cover something, or is more likely for a narrow interval to cover something?
It's more likely for a wider range to cover something.
Yes, exactly. If the interval is wider, it's more likely to cover something versus another interval which is narrower.
Oh,
Okay.
so it shrinks when you're less
Yes.
confident.
So when you become less confident, if you move from 99% to 90%, right? Okay. So you become less confident, right? You can get away with a narrower interval. Your interval is going to become narrower for less confident interval. It becomes narrower, right? Because it's more likely for a wider interval to contain something compared to a narrow interval.